Welcome to Teddy Talks. In this video, we are going to learn relative motion. Now, when we're looking at relative motion, we're going to look at it in two different parts. One will be relative velocity, and the other will be relative path. Now, straight away, let's go to relative velocity. What is relative velocity? This is the velocity of a body as it would be seen by an observer on another body. What is this statement telling us? That if you have maybe two bodies moving, maybe someone is in a Land Rover and then the other person is in a Primo. If these people are driving on the same path, the velocity with which the driver in the Primo sees the velocity of the guy in the Prado is what we are calling it relative velocity. So this is witnessed in a way that when you see this person who is driving the other car, the speed at which you see his car moving tends to be less than the real exact speed. So now that speed that when you try to see as if it is what is that guy is moving at is what we are calling it relative velocity. Now, let us look at relative velocity. Consider two bodies. A and B. If we are considering two bodies, A and B. Now, for these two bodies, if there is an observer in body A and he's seeing a body B moving, then we say that the velocity of B relative to A, that the velocity with which A sees B is called the velocity of B relative to A. So let's say that if the observer in A looks at body B moving with a velocity VB, okay? Now, the velocity of B relative to A is the velocity which the observer in A sees to be the velocity of B. He sees this to be the velocity of B, and is called velocity of B relative to A. Now, if the velocity of A, assuming A is moving with a velocity VA also, the velocity of B relative to A, this is denoted B VA or VBA. Now, when we look at vectors, we know that this is the same as velocity of B minus velocity of A. That the relative velocity of B to A is the velocity of B minus the velocity of A. For example, if you are moving in the same direction, and if the observer in A was moving in the same direction with the person in body B, then the relative velocity is the difference between their velocities. Now, another thing that you should know, that the velocity, the relative velocity of B to A is not equal to the relative velocity of A to B, since the relative velocity of B to A is equal to velocity of B minus A. Now you see, for this case here, this is VA minus VB, and if VB was greater than VA, when you substitute here, you cannot get the same result. So it is true, the relative velocity of B relative to A is not equal to the relative velocity of A, the relative velocity of A to B. That is, this has to be taken into consideration. Now, when we shall be calculating or looking at the problems under here, we are going to use two methods when dealing with the numerical problems. When dealing with numerical problems, we shall employ two methods. One is the geometric method. We shall use the geometric method, and then two, we shall use the vector calculus, or we can call it the vectorial method. Those are the two methods that we are going to use. Now let's look at the geometrical method. Of course, the geometric method, this is from geometry. Now, when we are using the geometric method, we have to be careful. One of the conditions or the situations that must be satisfied, the two velocities must be originating from the same origin, and they should close to form a triangle of velocities. That is condition number one. Condition number two, the relative velocity must be in direction must be in the same direction from the observer. So we can put it as an NB here, that the velocities must be originating from the same point, and they must close to form a triangle of forces. They must close to form a triangle of forces. Condition number two, the relative velocity should, in fact must be in the same direction as that of the observer. So those are the conditions that must be satisfied when we are using the geometric method. Now, let us look at the scenario here. if this is our observer and we have the velocity of maybe A, this is VA, okay, let's call it B, this is VB, and then we also have another velocity, VA here, moving in that direction. At the end of the day, their relative velocity is around here, and this will give us the velocity of A relative to B. This will give me the velocity of A relative to what? Relative to B. Now, if I call this point A and this is point B. Now, this is our triangle of velocities, and we have various angles. Now, for us to be in position to calculate the relative velocity of A to B, we either use the sine rule or the cosine rule. So here we can say that we either use the cosine rule, and what does the cosine rule say? It says the A squared plus B squared plus C squared is equal to 2BC cos A. Now, where is A? This is our side A, this is our side B, and this is our side C. So, if we put in our values here now, this will mean that this is VA squared is equal to VB squared plus VC squared minus, not C, this is VAB squared minus 2VB times VAB cos A. And from that expression, we shall be in position to get our relative velocity, the relative velocity of A to B. Then, if we do not want to use the cosine rule, we can use the sine rule. The sine rule for it says that A out of sine A is equal to B out of sine B, which is equal to C out of sine C. Now, what is angle C? Is this one. This is angle A, this is angle B, and the side that faces the angle is what becomes that velocity along there. So that is how we would use the geometrical method to calculate the relative velocity of a body. And please take note of these things. Be careful with them. Question comes, it is always simple and it always has a lot of marks. Now let's look at the vector method. If we use vector calculus, if we are using vector calculus, we know that the velocity of A relative to B is equal to velocity of A minus the velocity of B. So if we were given the two velocities, then we would calculate it from this one. Or the velocity of B relative to A is equal to velocity of B minus velocity of A. But you should remember that that the relative velocity of A to B is not equal to the relative velocity of B to A. Take note of this. Okay? We should take note of that, and let's end here.